2022 AP Calc AB FRQ problem number 5. So consider the differential equation dy over dx is equal to 1/2 sine x over 2 pi over 2x times root y plus 7. Let f of x be the particular solution to the differential equation with the initial condition f of 1 is equal to 2. The function f is defined for all real numbers. So part A, the portion of the slope field for differential equations is given below. Sketch the solution curve through the point 1, 2. So slope field on screen. So for problem number A, it's pretty much a free point. There's nothing really hard to it. All you have to do is follow the tangent slopes of throughout the graph and make sure that you hit the given point 1, 2. So it's pretty much an easy point. You can't really mess it up. You just follow the lines. So B, write an equation for the line tangent to the solution curve in part A at the point 1, 2. Use the equation to approximate f of 0.8. So first we have the equation, the slope equation, 1/2 sine pi over 2x times root y plus 7, and then we have to find when it's at 1, 2, the tangent line at 1, 2, and approximate f of 0.8. So we plug in the equation 1, 2, and then we get 1/2 sine pi over 2 times root 2 plus 7. And that eventually simplifies into 3/2 sine pi over 2, which is equal to 3/2. So the slope of the tangent line at 1, 2 will be 3/2. So we can put this into a tangent line equation, the equation for a tangent line. So y equals mx plus b. Y is equal to 3/2 x minus 1 plus 2, which is the slope of the tangent line at the point 1, 2. So now we have to approximate f of 0.8. So we basically plug in 0.8 as x value to know, plug in 0.8 as x value. So then we get 3 over 2 times 0.8 minus 1 plus 2, and then which is 3/2 times negative 1/5 plus 2, and that gives us negative 3 over 10 plus 2, which is 17 over 20. So the approximation of f of 0.8 is 17 over 20. So it is known that f double prime of x is greater than 0 for x for negative 1 to x to 1. Is the approximation found in part B an overestimate or an undermeasure estimate for f of 0.8? Give reason to your answer. So we're given that f double prime of x is greater than 0 through the interval negative 1 to x to 1. So and this interval, we have our tangent line is within the interval where it says that the f double prime of x is greater than 1. So we know that it's going to be concave up because the double derivative of the graph is above 0. So that means it's going to curve up kind of like in this shape, right? And then we know that the tangent line is going to be just a straight line going through the graph. So since our estimation is a straight line and the graph is actually curved up, that means that f of 0.8 will be an underestimate because it's going to be a straight line which is actually below the actual value of the graph of f of x. So D, use the separation of variables to find y of f of x, the particular solution to the differential equation dy over dx is equal to 1/2 sine pi over 2x times root y plus 7 with the initial condition f of 1 is equal to 2. So we have y is f of x, initial condition f of 1 is equal to 2, and with the equation, right? So first we want to separate the variables. So we have to separate dy, all the y variables on one side, and then all the x variables on the other side. So we multiply the left side, we divide left side by root y plus 7, and then we get 1 over root y plus 7 dy is equal to, and we multiply the dx into the other side, is 1/2 sine pi over 2x dx. And then from there we can both integrate both sides, and then we can simplify this equation into getting integral of, so this is basically y plus 7 to the power of negative 1/2 dy, and then the right side we have 1/2. We take out the constant, and then the anti-derived sine pi over 2x dx, which gives us negative cosine pi over 2x, yeah, and all of that divided by 2 because of the chain rule inside the cosine pi over 2x. And then we can't forget the plus c. So when we integrate the left side again, we get 2 times y plus 7 to the power of 1/2. That's the antiderivative. So, and then again, we can simplify the right side to make it more cleaner. So the 1/2 and pi over 2 cancel out into giving us, and the negative sign into giving us negative 1 over pi cosine pi over 2x plus c. So from this equation, we have the initial condition, which is f of 1 is equal to 2. And then if we plug in as x and the x and y values that they give us, we can find out the constant c. So you plug in y is equal to 2 and x is equal to 1, and that's going to give us 2 times 9 to the power of 1/2 is equal to negative 1 over pi cosine pi over 2 plus c. And then from there we can get 6 is equal to negative 1 over pi times 0, because cosine pi over 2 is equal to 0, plus c. And then obviously negative 1 over pi times 0 is equal to 0. So then we have c is equal to 6. And then we can finally plug c as equal to 6 back into the original simplified equation. So then that's going to give us 2 times y plus 7 to the power of 1/2 is equal to negative 1 over pi cosine pi over 2x plus 6. And then from here, all we have to do to find the particular solution is just to basically solve for y. So we have y plus 7 to the power of 1/2 is equal to negative 1 over 2 pi cosine pi over 2x plus 3. And then we square both sides to get rid of the 1/2. And that's going to give us y plus 7 is equal to negative 1 over 2 pi cosine pi over 2x plus 3. And then finally, the last step, all that squared. And then finally, the last step is to subtract 7 both sides. So we have y is equal to negative 1 over 2 pi cosine pi over 2x plus 3, all squared, minus 7. So that is the answer to the particular solution. So for this FRQ, there's nothing really that hard to mess up on. All you have to do is be slow and understand what exactly you're going to be solving for, and also make sure to not trip up on silly algebraic mistakes, as that could eventually get you a wrong answer for these problems. But basically, in general, this should be a free, easy FRQ to score good points on. So yeah, that's it for the 2022 AP Calc AB FRQ. So some more extra practice for differential equations is the 2021 FRQ problem number 5. It has some good equations involving tangent lines, and you can also do problem number 6. It has more slope fields and more particular solutions and differential equations. Another example is the 2018 FRQ number 6. It has a slope field, and it has more particular solutions with initial conditions to find. And then lastly, we have the 2016 AP Calc AB FRQ. We have another differential equation problem that is pretty useful, and along with the slope field. And then we also have the Macmillan textbook, where on chapter 7 differential equations, page 551, there's a good source of problems that you could practice if you need any extra help on differential equations.